Dear students, let me start the fifth experiment in the instrumentation. That is what we call as viscometry. The viscometry means using of a viscometer to determine the viscosity or viscosity coefficient of an given liquid. So I think you may heard this word viscosity also, viscometer also, as well as viscosity coefficient also, including of this word liquids also. So these all words are familiar. In that, so we have taken this any of the liquid, you compare with the water, so then we can decide what is of its viscosity coefficient. The unit of the viscosity coefficient is millipascal. It is denoted by eta of liquid, so eta of water, so viscosity coefficient of liquid, so viscosity coefficient of water. So as the same way we find out this viscosity coefficient, so we require the 4 to 5 values. So 4 to 5 values, one is density of liquid, second one is density of water, third one is viscosity coefficient of water and time taken of water. So all these 4 values we can enter. Then we can get the fifth values of a given organic liquid viscosity. So it means generally, so using the term of viscosity, what is the meaning of viscosity? It is this the friction between the two layers of liquids. It is especially 2 layers of solids also, still more is there. So in liquid compared to the solids are very less. So for it is we can compare this, we take the examples of 3 liquids. So one is water, pure water, another one is castor oil, so another one is petrol. So 100 ml of these 3 we can pour on the even surface of the any place. At the time, the movement is, first one is which is more evaporated and more thin is there, it is moving is fast. Second one is water and third one is, so we can what we call it as castor oil, because the castor oil viscosity is most, the water viscosity is average and petrol viscosity is very less. So for viscosity and movement is inversely proportional. So further, we can always comparing the viscosity coefficient of given organic liquid is with water, so we can call it as a relative viscosity coefficient. We are going to find out the relative viscosity. For that, so we can going to find out what is first viscosity. We know the viscosity friction between these 2 liquids. So two liquids, one liquid layers, 2 layers of the liquids we can call it as a viscosity. In water is average, in petrol is less, viscosity is more in that is a castor oil, so for its movement is very less. So inversely proportional. From this to find out this viscosity, then this viscosity coefficient, so we are, what is this viscosity coefficient also? That minimum tangential force is required to maintain the unit velocity gradients between the 2 successive layers of unit distance keep apart. It means we have taken these 2 atoms of or 2 molecules of water. The time the minimum distance is required to maintain the minimum velocity gradient is required. At the time the movement is very smooth, the liquid is very thin, and it is easily passing in anywhere also, even in capillary also. So far, at the moving of this in the capillary, how much of the time taken to the unit length? Whether you have taken the unit length is 1 meter, you have taken the 1 or 2 drops or 10 drops of water, you are passing from one end to the capillary tube to the another tube, how much of the seconds it has taken? So as the same way, you can passing of the petrol from one end to the another end of one length of capillary tube, you can pour it, how much of the time has taken, you can measure it in seconds. As the same way, you can pour this castor oil, so from one end to the another end of capillary tube, how much of the time taken, you have measured it, you have calculated it, immediately you are knowing of, well knowing of more viscosity, most viscosity is castor oil, average viscosity is water, very less viscosity of petrol, because petrol has taken the very less time, water has taken the average time to flow, and the castor oil is more time to flow from one end to the another end. So far, you can find out this one of the instrument. It is a glass instrument. We have used in this our engineering chemistry lab. It is a U-shaped one glass tube is there. In between that one small bulges or bulged portions are there. Out of this one tube shape, one side is, one leg is a little bit bigger and one side is small. Only we can calculate an amount. So this amount is this, where is the bulge portions are there. How much ml of we can using of liquids moving from upper end to this lower end. How much ml? It's a constant volume. So far we can do it. So both the sides in this we have taken this dried viscometer. It should be dried. Should not mix with any of the water, because it's disturb the viscosity and viscosity coefficient of water and any liquid. So far, before we can use, you can confirm the viscometer should be cleanly dried. And as well as after this tube, inner side one capillary tube is there. So that is, it is very useful to us to measuring the movement of liquid molecule from transferring from one end to the another end. Afterwards, naturally, with the help of the gravity, so it is marking of upper end to the marking of lower end. How much time has taken? Only it is a very simplest experiment. You can fill the dried viscometer to the liquid. So then we can measure this, how much of the time taken from upper portion to the lower portion of this viscometer moving of liquid. So as the same you can do it for 3 times. Afterwards you pour back into the beaker. So wash with acetone. So then it is, we can fill the DM water. Afterwards, what is the movement of water from upper into the lower? So far, so I have taken this one of the organic liquid. So slowly filled into this the large bulb of a given viscometer. So afterwards, I will fix to this one burette stand, and that we can prepare this water bath. It is only we have taken the 1 liter of beaker containing tap water. So it is completely immersed that larger bulb into the water, because this viscosity and viscosity coefficient are it is affected by the temperature. So far, if it is we have kept in the water, but at the time even the varies of the temperature also, this the movement of liquid from upper end to the lower end. It is we have taken these 3 trials. Out of these 3 trials, little bit varies will come. So far, instead that we have conduct to measure the viscosity coefficient of given liquid, we have the better option to dip it into this water bath containing of a tap water. Tap water we can use it. So now we have to fix it. So afterwards, we are using of this time taken calculations of this. So then, so we can so starting this, we can transfer the liquid from larger bulb to the smaller one. For this 2 to 3 times we have done it. So we are measuring, it is up to this, it has come from larger bulb to this smaller one. So it takes so maximum is 1 minute to transfer. Okay, I've done it. So using of this stop track, so now I am starting to this movement of the liquid from upper mark to the lower mark. So that is the seconds we have counting. So at that time, so we have written of this tabular column on this board. So it is one for time taken for liquid Another one is time taken for water and 3 columns, 2 rows and 3 and 4 columns. So that is how much of the time taken for water and how much of the time taken for liquid. So from this, so we can neatly estimate that how much of time taken from upper mark to the lower mark. So now, so it has taken off 90 seconds. Taken off 90 seconds. The moving of upper mark to this smaller bulb to the lower bulb. So this 90 seconds has taken. So I have repeated for the second time also. That is, we can take the rubber bulb. So it is the carcinogenic. So don't use up your mouth to this moving of liquid from larger bulb to the smaller one. Again, we have taken this rubber bulb fixed to this, we can pressure it with. So then it is fixed to the mouth of the smaller bulb. So then automatically, easily transferred. You can remove your pressure with of your thumb, easily transferring of given liquid from larger bulb to the smaller one. So when it is come back to this upper mark, at the time you can stop it. So afterwards you can start the same stopwatch. Don't change the stopwatch and afterward viscometer for all these 3 trials of liquid and all the 3 trials of water also. In between, using of water and including of liquid, you should use the same afterward viscometer. Otherwise, you won't get the exact viscosity coefficient. What is already we have determined in our lab. So in our lab temperature, including of lab record. So far, so it is the sizes of any minute sizes of inside the capillary tube is varied. At the time, it is taken as if use different, we can get the wrong result, we can get the error at the time. So we can, so it is no use to find out the viscosity. It is wrongly find out the viscosity coefficient. So far, better using all 3 trials of same viscometer of liquid, all 3 trials of same viscometer of water also. So this first time I got it, time taken for liquid is 90 seconds. Second time is 91 seconds. So second time is 91 seconds. So I can repeat it for next trial also. So next trial, so take this rubber bulb and easily transferred from larger bulb to the smaller one. So then it is, we can start to this for upper end to the lower end movement of liquid. Before that, ensure of no air bubbles as well as and including of no impurities are there. So at the time, so it is almost all, not even any variations of 1 or 2 seconds. Maximum is 2 seconds, minimum of 1 second. If you very exactly you can maintain also, not even 1 second varies also, you won't get it. Suppose it is any of these variations of this liquid movement, because you can change these liquids of at the time it is varied, including it is temperature. If the temperature is increases, the movement time is less, the movement is speed. So far, the inversely proportional to temperature. Suppose you can taking up any other organic liquid. So number 1 liquid, 1 to the number of organic liquids are there. All organic liquids viscosity coefficients are very, very different. It is not matching with one to another. Almost all water viscosity coefficient is same with of this chlorobenzene. So that is almost all equal. Other than that, more viscosity is to this aniline, less is nitrobenzene. So nearby water is equal to this chlorobenzene. Next to the water is benzene and toluene. So far, so easily we can given out these 2 categories we have done. So this time it has taken 90 seconds. So the 3 trials are over. First trial is 90, second one is 91 seconds, third one is 90 seconds, So we have taken the averages of all these three, 90.02 something it will come. So the average reading of time taken moving of organic liquid from this upward viscometer from upper end to the lower end, it is we regarded as a 90. So afterwards I taken this upward viscometer. So pour this of organic liquid into this bag of the given sample collector, that is 100 ml of beaker. So afterwards I can wash with the acetone. I can wash with the acetone. This acetone water I can fill this acetone to this larger bulb. So from this larger bulb to this completely filled. Afterwards it is transferring from larger bulb to the smaller one using of the same, that is what we can call it as a rubber. So don't suck it. So afterwards it is pour back into this acetone bottle. So don't waste the acetone also, don't throw this organic solvents also. Then this is keep it for 50 to 20 minutes in the hot oven. So hot oven. So this afterwards we can taken back of same also. You can assume this it is completely dried. So it means you can wait for 15 minutes. So we are not at the time of recording, we have not done it. So then it is fixing to here. Afterwards we can fill the given water or lab water to the large bulb of the viscometer. Large bulb of the viscometer filled this water. So suppose this water is possible to suck away more, but don't, you can try it again to these principles. Again you will take this rubber bulb and transfer from larger bulb to the smaller one. So afterwards you can fill it using the same stopwatch, moving from upper mark to the lower mark. So at the time, so we are watching, so from upper end to this lower end. So this is might be. So we have given to you if it is benzene or toluene or chlorobenzene, that is we have taken this time taken is more bigger thing. Suppose we have given to you this benzene instead of this benzene and chlorobenzene or toluene, we have given to you nitrobenzene or even aniline. At the time the water is less. Time taken. This organic solvent is more time. So now, so this is coming from upper end to this lower end. The time taken is 110 seconds. Don't write it in the minutes. So 110 seconds I have written it on the board. So then it is passed on to the second trial of this water. So it is transferred from upper, that is larger bulb, to this smaller one, completely filled. Afterwards I can use the same stopwatch, moving of solvent from upper end to the lower end. How much of the time it has taken, you can make very neatly. So don't neglect it. If it is neglected, variation of the times, of course if temperature is varied also, itself it is varied. Increasing the temperature, decreasing the viscosity coefficient. It is inversely proportional. So for one to the another, how can it is varied? So in between to that, so it is the branch molecules are more, the thicker branch molecules are more, automatically it becomes thicker, more molecular weight, more equivalent weight, the temperature is varied. At the time, the movement of the same liquid also, and the time is different, so from upper mark to the lower mark. Of course, in this within 1 or 2 minutes, the temperature is varied at 1 or 2 degrees also. We have kept into the water bath automatically, which is not maximum effect to the movement of the liquids. So this is it is taking off from coming to this last end, that is 1/12 second it has taken place. So I can repeat for one more time, transfer from larger bulb to the smaller one. So it is transferred. So afterwards I can start from moving this liquid from upper end to this lower end. watching to that almost all. It is 110 second, 112 or 11. So that is one. If it is third trial, you can get it as 90 or very abruptly varied of the time seconds. What you already recorded, you discard that. Again, you will repeat from this transferring of liquid from larger molecule, larger bulb to the smaller one. So then you can take the fourth trial. So in almost all 1 second or maximum 2 seconds. If it is still more varied, you don't take that values. You can repeat it for again also. So now it is I can waiting for this 111 seconds. You can got it. Stopwatch is also stopped, and I can return on the board. So this 110, 112 and 111. I can take the average to all those things. So 1111. Why do we take all these averages? Means if supposed to be this temperature is varied also, even we kept the upward viscometer in the water bath, that should be coming the variation is below the 5%. Our aim is very clear. Below the 5% of variations that should be occurred because of the temperature variations. We have taken the average for this experiment only. In any other experiment, we have not taken any averages values because it is effect of temperature. The liquid movement is effect of temperature. The temperature and pressure does not vary the constant values of the analyzer. We won't take average. So because of this inversely proportional or directly proportional of this movement, any of the things, it is the variations of values because of temperature and pressure. At the time only we have taken the R. So then we are using the viscosity coefficient formula. That is viscosity coefficient of liquid is equal to time taken of liquid divided by time taken of water. So into density of liquid. Density means the molecular weight, mass by volume. So density of water divided by the viscosity coefficient of water. How can you find out this viscosity coefficient of water is using this Poisson formula and utilizing pi r to the power of 4 pt divided by 8 L. Already know it, this values are pi. This is r for radius, p for pressure, t for time. So L for length of this tube, and it means the volume. What is its size? This everything we can calculate immediately. We can get this any of these, all these solvents. This viscosity coefficient is fixed with respect to the temperature. If temperature is varied, then liquid movement is varied, then liquid density is also varied, and viscosity is also varied, viscosity coefficient is also varied. So far, so immediately time taken is 90 of liquid, time taken of water is 1111, multiplied by density of liquid. We have given from this our table. The density of water is also given from the table, and this viscosity coefficient of water is also given from the table. Afterwards, we can easily calculate all those things after substitute. Then finally we can find out. So that is, we can get it as 6.02 by millipass. This is the viscosity coefficient of even organic liquid. So it is varies temperature, with different values also you can it as. Afterwards, other than this, no pressure is because gravitational pressure is only on there. So finally, we can go into what is these values is that millipass of viscosity coefficient of given organic liquid we can find out. So without the water we could not find out. Suppose to find out also, so at the time of comparison, which one is flow easily, which one is flow less, which one is flow more. At the time only we can compare. Better we can use the upward viscometer, relative viscosity we can find out, and we can announce in this very exact answer what is there in our table we can give. Okay, thank you.